Okay, so on this problem, let me zoom in so you can see. We have a teacher who is currently teaching two statistics class. One is at 8 and the other is at 10. And then there's a table that summarizes the attendance records by showing the probability of the number of absent students per class. So we're looking at students, and we know students, the number of students cannot be a fraction or decimal. So this is a discrete probability distribution. Now the table, I ended up copying it over, and let me make it a little bit smaller here so I have room to work. I ended up copying it over from the homework. Since I copied this image, I can't click on it. But we want to calculate for A, let's look at it again. Calculate the mean number of students absent for each class. So the mean of a discrete probability distribution is this formula right here. Expected value is the same thing as mean. And so we want to take x times the probability of x for each row. And we want to multiply those and then add them. So the first one we have is 0 times 0.05, which is 0. We have 1 times 0.14, because this is x and this is p of x, and we're just multiplying across. And then we have 2 times 0.31. We have 3 times 0.19. And I'm looking at only the 8 a.m. class. Okay, and then 5 times 0.09. And that is going to be 0.45. 5 times 0.09. Okay, so now the formula says after we multiply, order of operations says multiply first, then add. So when you add these together, you should get 2.66. Okay, I had to pause it and put the right problem up here. So you should get 2.66. Now, for the mean for the 10 a.m. class, we're going to do the 10 a.m. class. So that's still going to be x. This is 10 a.m. I mean, this is 8 a.m. Down here, I've written x and p of x. So now I just need to multiply and get x times p of x. So if I do that, I will get 0, 0.31, 0.56, 0.42, 0.32, and 0.25. So now I need to add those in my calculator, and I will get 1.86 for the mean of the 10 a.m. class. So if we look up here, you can see that it's 1.86. Okay, now we have to calculate the standard deviation for the number of students for each class. So this is a different formula, and I will put that formula up now. Okay, so for our formula, the standard deviation for a discrete probability distribution says to take x, square it. So let's do that first for the 8 a.m. and even for the 10 a.m. the x squared will be the same because x is the same. So square each one of those. 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. Okay, now we're going to copy the probabilities down for 8 a.m. 0.05, 0.14, okay, so now I just need to multiply x squared times p of x. So I'm going to do that. This is going to be 3, so I'm just multiplying 4 times 0.31, and then you can use a calculator to do this. 1.71, 16 times 0.22 is 3.52, and 25 times 0.09 is 2.25. So now we need to add those together because the formula says multiply x squared times p of x. Now sum those numbers up. Okay, when you add those, you're going to get 8.86. So now this is the formula for the variance. So let's find variance, and then we can just take the square root. So plug it into my formula. I just did everything in the parentheses. My mean is what I calculated in part A, which is 2.66. So 2.66 squared, and you're going to get 1.7844, and you need to take the square root of that to get your the standard deviation. So when you do that, you're going to get 1.3358, but we're rounding to 2 decimal places, so that would round up to 1.34. Okay, now we're going to do the same thing for the 10 a.m. So I'm going to have x and x squared, and what I'm going to do is just erase, because the first part will be the same. And this is going to be 10 a.m. this time. So now I'm going to do copy my probabilities over, and this time I have see if I can move this or make this a little bit smaller. There we go. Oh. Alright, so 0.14, 0.31, 0.28. I'm just copying my probabilities. Now I just multiply here. Okay. Now we're going to add those numbers together, and you will get 5.22. Now we need to finish. We did the parentheses for the variance formula. We need to subtract. I'm looking at this formula right here. We need to subtract the mean, and the mean for the 10 a.m. class, if we look at that, is 1.86. So we are going to subtract 1.86 squared. So if you do 5.22 minus 1.86 squared, you're going to get 1.7604. And we know for the for the standard deviation, we take the square root of that, and we get 1 1.3268, but I'm going to round it to 2 decimal places, so we get 1.33. So there are 2 formulas when you're talking about discrete probability distribution. You have the formula we just used, which is the variance formula. If you want the standard deviation formula, it's just the square root of that. And then you have the mean formula for a binomial distribution. So I hope that helps you. There are a lot of steps, so take it one step at a time and let me know if you have any questions.